All right, question number 17. So I would suggest you to stop the video and try the question on your own first. Now, question number 17, you're gonna cover section 9.1, and 9.1 is about testing a difference between two means using the z-test. All right, so let's get to it. So the first question is asking you to state H0 and H1 and which one is going to be the claim, and I guess here you're going to be two tail or one tail, right? So let's see. So we need to identify the claim first. So always whenever you're doing these questions, there is a sentence in the, it should be there, and it should tell you the claim, what the researcher here, what he's trying to do. So the first sentence is the indication of the claim. So the researcher wishes to see if there is a difference between the mean number of hours per week that the family with no children participate in recreational activities and a family with children participate in recreational activities. So basically this is the sentence of the claim. So mainly they are saying here that if this is mu1, this is the mean, this is the mean number of time that no children family spent into recreational activity, and this is mu2. So the claim here is stating that we want to figure out whether mu1 is different than mu2. All right. An alternative one to write it down, you can write it down mu1 minus mu2 is different than 0. All right, and obviously because there is a different sign here, this can be only h1, it can be h0. So this is my claim. Obviously h0 would be the other side of the coin, which is mu1 equals to mu2. All right, or you can write it down mu1 minus mu2 equals to 0. All right, so this is should be the answer for your first question. So every time we have mu0, by the way, equal sign here, so this is going to be a two-tailed because there is a difference for the claim mu1. So this is my normal distribution, and we are having, well, this is the difference mu1 minus mu2. All right, so this is supposed to be equals to 0 here, and we want to figure out the two tails here, this part. All right, so this is a two-tailed distribution. So they are the two tails, and these points here, they should be the cutoff. So we're gonna figure out actually this what will be later on. All right. Okay, so let's put the information. So for H0, you're going to be equal sign mu1 equals to mu2. This is not the claim. And for H1 would be mu1 different than mu2. And this should be the claim. And this should be two-tail. Check the answer. And it did work. Great. So now they are asking you about the critical value. All right, find the critical values and round your answer at least 2 decimal places. Now the critical value is always connected only to the alpha. So every time they ask you about the critical value, this is the alpha. So now if I have two tails, right, two-tail distribution, then the alpha should be distributed in these two tails over here, which means I'm gonna put in here alpha over 2, and I'm gonna place here as well alpha over 2, and this is gonna be 0.01 divided by 2, which is equals to 0.005. all right, so now I want the t critical. There are obviously two of them. So this is t alpha over 2, that's one of the t criticals, and the other one minus t alpha over 2. All right, and this is the second one. Now how can I get it? It's simple. The calculator will require that you feed it the left tail for the first one. I think this is the easiest one to find, so I need to place the left tail, and we are using the z table, so I'm going to be using inverse z. All right, inverse normal. So first of all, let's turn on the calculator. Second, and go to vars, and I'm gonna go to inverse normal, enter. So here I'm gonna place that the value of alpha over 2.0050, and the mean is 0, sigma is 1, leave it as it is, and here you're gonna be enter and paste, enter. So this is gonna be minus 2.5758. All right, I'll round it in a moment. So 2.5757, I think 5, so it's gonna be 58. All right, and let's go back. So there are two critical values, and we wanna two decimal places, 2.58, right? So two of them, I can use the plus minus, I guess. So let's see the plus minus, and 2.58 here. It should be enough. All right, so check the answer, and it's good. All right, so the third question, we are trying to compute the test value. All right, so the test value is kind of complicated for this. So just to remind you about the formulas. Here, they are both formulas here. So this is the z value that you are looking for, which is the z test. All right, and this is a confidence interval in 9.1. Now, obviously, I'm not going to do this. I'm going to try to make a shortcut and use the calculator instead. So how can I use the calculator for this one? And what you're going to be doing is, actually, there is a test here. The test is already built in the calculator, so you need to find it. And the way to do the test between two means, you're going to go to statistics, and then you're going to go to tests over here, this table. So obviously, we are doing a test of two sample z-test. All right, there are two samples there. So once we enter here, so we have two options, either the data, and if you have the data, you're going to be provided with a list. All right, so this is in case you have all the numbers. All right, obviously we don't have the list, so we're going to go on the side and we're going to click on stats. So stats, what does mean? This means you are already provided with the average, the standard deviation, and n, and this is the case as you see it here on the table. So I'm going to just plug in my information there. So the sigma is going to be 2.4. This is for sigma 1. Sigma 2 is going to be 2.9. I'm going to go x1 is going to be 8.8 here. And now n1 is 34. And right now x2 is 10.4, n2 is 34, and now I'm gonna tell whether it's a two tail or one tail, so left right, but I have here mu1 is different than mu2, so that's what I'm having. Enter, and I think that's it. I'm not going to draw it, I'm just going to calculate this. So the calculation is done. Really simple. So the value that you're looking for, which is the z value, all right, so the calculator here, the value is given by the calculator, and the z test, all right, as you can read it here, is minus 2.478. now you can round it to two decimal places, so you're going to be minus 2.48. all right, and let's go and check it. So we're gonna be minus 2.48 here, 2 decimal places. Let's check. Yep, it's good. Great. So now we want to make a decision. So what does mean? We're gonna decide whether to reject or accept. This we will need the graph here. So for the graph, these two critical values that we just found over here, this is the first critical value, this is the second one. All right, now this critical value divide my chart in two parts. So the inside part, this is what we're gonna say the acceptance zone. It means accept 80. All right, so if the z-test falls here, we're gonna accept 80. However, if you're gonna falls outside, we're gonna reject 80. So my logic is always related to 80. All right, so now if I wanna place this number in here in the chart, so obviously this is 2.58 minus 2.58, therefore the minus 2.48 is gonna be somewhere here. So this is my z-test, which is minus 2.48. Therefore, is, as you can see, is falling within the acceptance zone. So the conclusion here is going to be accept 80. All right. Now, what the meaning of acceptance 80? It means we do not have enough evidence to reject it. All right, or to support H1. Not enough evidence to support H1. Supporting H1 is rejecting 80. It's some same thing. All right. Okay, so let's see what we got on the question. So we know we're gonna accept 80. Are you, well, accept means do not reject the null hypothesis. Check it. And the last one, there is, all right, there is or there is not enough, right? There is not enough evidence to support the claim. That's what we said earlier. All right, so we don't have enough evidence to support the claim. It means we don't have enough evidence to reject 80. They are exactly the same thing. And check it and done. All right, I hope this will help.